I'm standing between you and lunch, and that's not a good thing. So we'll try to make this go.
Not the
There's
only
one more
ones.
after.
Yeah.
Oh, and there's a panel.
No. The panel's after.
Panels after. Okay, so they won't be too hungry. We thought we'd have a little bit of fun with this and have two presenters. So we're going to do a bit of a tag team. As he said, I'm the Wi-Fi guy at Ericsson, and Derek is responsible for the work that we're doing in LAA in Ericsson. And yes, we actually talk together all the time, right? So, but seriously, I think Ericsson's in a very good position to be able to talk with pretty good authority on this topic. And what we wanted to try to do, there's a lot of misconception, there's a lot of myth, there's a lot of noise on this whole topic. So we'll try to present the facts, both from an LAA perspective and from a Wi-Fi perspective, and see what you think. So the agenda goes something like this: why unlicensed spectrum? Eric will explain, LTE advanced. He'll explain to you the differences between LTE-U and LAA. You heard a bit of that already from the gentleman from Qualcomm. We'll talk a lot about coexistence, and there's been a tremendous amount of good work done there. I won't not talk about Wi-Fi technology evolution because it's something I'm proud of and it's my baby. We'll talk about applications, and then we'll make some concluding remarks. So the thing that's driving all of this, of course, is spectrum. And as we know, there are two basic modes of utilization of spectrum in the mobile broadband industry. One of them is licensed dedicated spectrum, which of course is what the mobile operators use and have been using for years. It's the mainstream approach for delivering mobile broadband networks. There's about 400 megahertz of licensed spectrum today, and all of the estimates that we see say that we're going to need something like 1,500 to 2,000 megahertz of licensed band spectrum by 2020. That's a lot. On the unlicensed side, which those of us being Wi-Fi people know all about, there's over 500 megahertz available today below 6 gigahertz. And if you include the higher frequencies, there's much, much more than that available unlicensed. It, of course, today is widely used by Wi-Fi for enterprise, residential, and a lot of, we heard cable operators this morning, a lot of fixed operator applications. And it seems pretty clear that unlicensed spectrum will become part of the 5G network paradigm. Of course, there are differences between those two modalities of spectrum, aren't there? Licensed band spectrum is particularly good for large area coverage and population coverage. People debate this over and over again, but even me, the Wi-Fi guy, will admit that the quality of service that you get on the licensed spectrum is always, always predictable. And of course, because there are billions of mobile broadband subscribers, it's affordable. There's tremendous economies of scale. Well, there are tremendous numbers of Wi-Fi devices as well. So the unlicensed band is affordable and offers economy of scale, but it's really best suited for short-range applications, indoor applications, hotspot applications. And there are variations in the quality of service that you will get from a Wi-Fi unlicensed band technology. So unlicensed spectrum is available today to augment mobile broadband network capacity, and we think it's just going to get better by using LAA. And that's where I hand over to Eric.
Thank you, Stephen. And I'll take the clicker as well. Thank you. So you already heard a bit about LTE from Sanjeev's presentation. I'll give a slightly different perspective, one that comes from an infrastructure vendor that's been providing equipment to cellular companies, many of which you've been your subscribers of. So LTE is obviously provided in a very macro type of network environment. And so we have cell towers that provide very large coverage for your LTE service. But one of the problems that the operators continue to work on is to fill all those coverage holes that were discussed earlier today. So when you walk into a building, you suddenly sometimes lose your coverage, and then you lose your service. So of course, you can use techniques, as were described before, to perhaps land yourself onto the onto a Wi-Fi network, a Wi-Fi network provided by the enterprise, or the operator themselves can continue to build out coverage so that you have good experience both indoors and outdoors. And that's where small cells comes into play. So operators are increasingly looking at small cell deployments. Now, one of the ways to use this licensed and unlicensed spectrum together is when you're getting into these small cell environments where the operator is trying to lift their offering, their coverage to you as an end subscriber. So I'll keep it rather brief on the primer for LTE because Sanjeev did a great job of describing that, but just visually representing it slightly differently. You see that license-assisted access uses a capability called carrier aggregation. Your phones that you might have in your pocket, oh, not this one, but this one, the iPhone supports carrier aggregation. That means that when the operator has multiple bands, they can pull them together to give to your device at the same time. So to increase your overall end user experience as you move throughout the cell coverage. Well, that same technique to combine multiple bands gets used to pull in the unlicensed spectrum, exactly the same. Now, when we're looking at the unlicensed spectrum in the 5 gig range, we're typically talking about downlink only at this point in time. But as you as an end subscriber are getting data from the network, that traffic can be scheduled on either one of the two carriers and delivered to the mobile. At all times, though, we keep the anchor carrier available for all the control signaling. The anchor carrier, of course, is the license band, cannot be interfered with, and therefore it's always stable from a control channel perspective. We opportunistically use the unlicensed spectrum for transmission of data. If it doesn't work because there's interference, we can immediately realize the fact that it didn't get transmitted successfully and continue transmitting on the licensed spectrum as if there hadn't been any interruption or very little interruption. Sanjeev talked about the different forms or different types of license-assisted access. So the first one is called the LTE unlicensed, LTE unlicensed. The LTU forum is sort of coined that term. It was, as Sanjeev said, initiated by Verizon with a lot of companies that supported that and working very diligently to make sure that the techniques that we brought to the table would operate, coexist in an equitable manner with other uses of that spectrum once deployed. And then what's continuing on in the 3GPP is this release 13 that we talk about, using listen before talk to address the markets that have much more constrained requirements on the use of that unlicensed spectrum. So turning our attention to that first version, to the first version that we've been working on with in the context of the LTU forum with Verizon. So the solution that we want to have, we want to make sure is coexists in a very good way with the existing use of the spectrum, so Wi-Fi in most cases. What this slide shows is a type of approach that we take. First, we don't use very much of the channel. We first find a channel that's not heavily used, but whatever channel we land on, we constantly monitor. And we start by, you might say, using a very small portion of that, say 10%. And then during the rest of the 90%, we monitor how busy the channel is. And if it isn't very heavily used during the other 90% of the time, we step up. And we continue to monitor what the rest of the channel is being used the rest of the time. And we continue to step up until we find a good operating point. But if the Wi-Fi, if the use during the rest of the time becomes extremely loaded, let's say Wi-Fi becomes full buffer for some reason, we immediately start stepping down and giving that room back to the existing use of that spectrum. And if we reach the point where we reach the minimum level, we just stop on that channel and we go find a different channel to work on. So in that manner, we opportunistically use capacity that is available in that unlicensed spectrum. When we of course work very diligently. We work with our Wi-Fi colleagues as well to make sure that we have good simulation environments that allow us to evaluate the performance of the system. These are types of simulation results you can find in the forum document. But basically, they show the behavior of the coexistence. On the left-hand side, you see Wi-Fi and Wi-Fi. The median, the blue and the purple, being two different Wi-Fi operators, and then and looking at both the median and the fifth percentile, and you see there's a reasonable amount of fairness between the two Wi-Fi APs, and then we replace one of those Wi-Fi APs with an LAA AP. And then you see the resulting behavior on the right-hand side with a fair amount of, with good coexistence between the two. And but the ultimate result is that if you look at the performance of the Wi-Fi, it is better on the right-hand side than it is on the left-hand side. Not by much in this particular simulation, but it always recurringly comes up, as Sanjeev said, that we get that performance. It ultimately becomes better than it was before. When we look at the forum, many companies contributed. We get similar types of results from other companies, not just ourselves. What I showed before was our results for our scheduler, but others have different schedulers and they have similar results. And that's what's shown over here. Basically, what you're seeing is the relative performance of two Wi-Fis. Here you replace one of the Wi-Fis with LAA, and you see on the left-hand side the resulting performance on the unlicensed, LTE unlicensed relative to the Wi-Fi, and then on the right-hand side the relative performance of the Wi-Fi against what it was before. And again, it's better than, it's in a positive territory. Sanjeev already talked about the work that's happening in Release 13. Just to visualize it. The work item will end by the end of this year on that, after which we will start talking about implementations and devices ultimately reaching the market in perhaps 2017. That's why there is the LTE Unlicensed Forum, is because the operators did not want to wait. The capacity crunch is today. It's not in 3 years from now, it's today. And so that's part of the reason why the activity initiated already, but continues on in 3GPP. Characteristics of what's happening in 3GPP you'll recognize. It does clear channel assessment. It has a very short duration duty cycle that's possible. In Japan, there's an extremely short duty cycle requirement of as little as 4 milliseconds. 3GPP is making sure that they're designed for that scenario as well. So we support both the clear channel assessment and that very tight duty cycle constraint that exists in some geographic regions. And some of the simulation results, or all the simulation results from all the companies that are supporting the activity are being driven into that study item. They're being consolidated right now. But what you see is the type of results that is on the right-hand side. So we constantly are updating or reviewing what methodology we're using to analyze the good coexistence between different technologies in that spectrum. This is one of the sample results. You can look at the technical report for all the results that are being consolidated. It's all public information, but basically you get this type of result where on the upper part, again, two Wi-Fi scenarios, and on the bottom you have one of those two Wi-Fis replaced with LAA. Now the reason for the curl back here, you might ask, is it a simulation error? No, it's not a simulation error. This is actually because one of the two Wi-Fi APs is doing a lot of uplink traffic as well as downlink traffic. And when that happens, what you get is the Wi-Fi that is more downlink centric ends up getting, you might say, starved to some extent by the other network that is both doing uplink and downlink. So that's related to the properties of Wi-Fi, where when you have many stations that are all driving, contending for the same resource, you get a bit of this behavior. Of course, we want this to work well. We have a Wi-Fi business, we have a cellular business, we want it to work well. We're obviously doing a lot of lab tests today. We demonstrated the coexistence behavior in Barcelona. We're continuing with field trials. We'll be doing field trials later this year where we'll be actively testing live, real-world environments where LTE unlicensed is operating in conjunction with Wi-Fi, and we'll be able to publish those results as well. And of course, looking into Release 13, we're a bit earlier in the design cycle for that, and we have test beds that are underway to again validate our simulation results. And finally, before I turn back to Stephen, just wanted to conclude by saying that we have a number of products that have been announced. You might the one on the left-hand side is a fairly small form factor enterprise device called the 6402. That's a Pico RBS, and that device has LAA, has LAA, the unlicensed portion, and has Wi-Fi. So we do have products that service the whole range of technologies that a cellular operator might want. So as I said, it's got 3 technologies in it. Both licensed, unlicensed, LTE, as well as Wi-Fi, all operating at the same time. And on the right-hand side, we have a system that's been publicly discussed as well. Radio dot looks like little, what you might say, smoke detectors, and those can be very effectively deployed in large enterprises for very efficient indoor coverage. Okay. Stephen, you're going to finish? Yeah.
Thanks, Eric. So I'll not let you get away without at least talking a little bit about my Wi-Fi, right? So Wi-Fi technology is pretty impressive these days. 802.11ac Wave 2 giving you about 4 gigabits per second of peak throughput. That's pretty good. And it uses a lot of the techniques and technologies that Eric already mentioned. Aggregation is something that we do in Wi-Fi. Downlink multi-user MIMO, which is something in LTE we also use in Wi-Fi. So we're not snoozing over on the Wi-Fi side of the house. And the interesting thing, the next steps that are coming are also trying to solve the same challenges of coexistence. So the work that we're doing with the variety of carrier Wi-Fi performance improvements in the Wi-Fi Alliance are very much about trying to make the performance of dense Wi-Fi networks better. And similarly, the work that's happening in IEEE in 802.11ax, this thing that we call high-efficiency wireless LAN, is also about trying to deliver something like a 4x performance in aggregated system throughput when you have overlapping Wi-Fi networks. So everybody's trying to work on this coexistence problem. The other thing I wanted to quickly talk about, to try to set people's minds at ease, I think, is that the application space, the market space that is being delivered using Wi-Fi is what you see here. The enterprise Wi-Fi space that we know and love, which is a big market, the residential Wi-Fi space in the middle, and then this thing on the right that a lot of us have been talking about to do with carrier Wi-Fi. And those bubbles are sort of to scale in terms of the size of the market. Now, what's LAA all about? It's the opposite, right? It's all about delivering small cells, improving the mobile broadband experience indoors and outdoors in selected locations, but still it's about delivering access for you as a subscriber to an operator. Yes, the operator will use LAA technology to improve the performance indoors in the residence, and will use LAA technology to improve the performance indoors in the enterprise as well. But you can see the complementarity there in terms of the applications. I wanted to close the loop in terms of unlicensed spectrum, because that's really where we started, remember, with the licensed versus unlicensed. And we really feel very strongly that unlicensed spectrum has been and should continue to be used by many, many technologies. I mean, in my history, I've seen unlicensed band fixed wireless systems. I've seen unlicensed band wireless backhaul. We have Zigbee, we have Bluetooth, we have cordless phones. Over the last decade or more, Wi-Fi has done a tremendous job of utilizing the unlicensed spectrum, but it's not the only show in town. We have to promote ongoing technology innovation in the unlicensed spectrum. It increases the value and efficacy of that spectrum. So it's the right thing to do. And LAA is an example of that ongoing technology evolution. Just some concluding remarks then. So LTEU and LAA are kind of the new kids on the block in the unlicensed band, and they're all about trying to improve the operator's capacity, the mobile network operator's capacity using unlicensed spectrum. Wi-Fi is clearly a technology to be reckoned with because it's deployed so widely today in residential and enterprise settings, so we have to take it into account. And as Eric has shown, and as the Qualcomm representative showed, LAA and LTEU will coexist very, very nicely with Wi-Fi, and in many situations offer higher efficiency. And as you saw from the products that Eric proudly showed you there, the indoor solutions are going to include all of these technologies in a single package. Licensed band LTE, LAA, and Wi-Fi, you're going to see it all integrated in one package. We really think that new technologies like LAA increase the value of unlicensed spectrum, and it's very clear to us that LAA is an important step along the way to enabling unlicensed applications as part of 5G networks. Thank you.
Thank you so much, Stephen Raymond, Eric Parsons.